listeners. I am Dr. Anuj Sharma, working in Center for Advanced Studies, which is in-campus research institute of Dr. APJ Abdul Kalam Technical University, located in Lucknow. So, we are discussing the fundamentals of mechanical engineering and mechatronics for first year students of Dr. APJ Abdul Kalam Technical University. So, this is the fifth lecture, which is based on beams and their classification. As we know, the beams are very important element of the mechanics of solids. If we see its practical application, so beams are very important members. So, we will take some topics related to the beams, their classification, different types of beams, different types of loads and support reactions on which the beams are placed, and then we will draw the free body diagram of different beams subjected to different loading conditions. So, there may be different types of loads. So, we will discuss one by one. So, basically what is a beam? So, first of all we should know what is a beam. So, beam is the structural member basically if we see from the diagram. So, this may be the horizontal member supported by some supports, let us say for example, this we will discuss, and this is the member. This member is the beam. It is always the horizontal structural member. So, generally whenever we want to draw or we want to construct any structure, so we need these kind of structures, and we apply load in the vertical plane, like this is the W1, this is W2, and let us say this is W3. So, these are 3 loads. So, this is the structural member. So, we will should say structural horizontal member, though I am writing the points which are very important to remember. Structural horizontal member, it bears the vertical loads to resist the deformation or to support these loads. So, basically the structural members are applied on any, or they are provided in any structure, or like just like we see the building wherever you see the construction going on around your society or your school or your colleges, where you will see many buildings are being constructed. So, initially what they do the foundation. So, let us say this is the foundation, then there may be the vertical members like this, and then they draw the horizontal beams, then again vertical member, then the horizontal beams. So, these members are known as the beams. So, these members are known as the columns. So, this is beyond the scope of this subject, and this is the beam. So, basically the complete load of the building comes on these 2 members. First is the beam, second one is the column. So, columns are the vertical members. So, here our study would be focused only on the beams. So, how we can classify the beams? So, beams can be classified into different categories. So, first maybe if we see the classification of the beams. So, they may be 2 types. One is the statically determinate, another one is the statically indeterminate. So, before understanding this, if you want to understand what is the statically determinate beam, what is statically indeterminate beam. So, we should know the equations of equilibrium that we have already studied in the 12th class physics. So, let us say if there is a body. So, first we will understand what are the equations of equilibrium, because then only we can understand the statically determinate and statically indeterminate beams. So, whenever this is a body, let us say this is the body, it is placed in the space. So, if all the forces, let us say many forces are acting in this direction. So, if we want to sum all the forces, because force is a vector quantity and we want to sum the forces in the x direction. So, if this body will have the unbalancing in the x axis, so this body can travel. Let us say this is the body, if many forces are acting on this, so this body may move in this direction. So, if we want to restrict the motion of this body in the x direction, so what should be there? So, the net forces in the x direction should be 0. So, it means this is the algebraic sum of all the forces in the x direction must be 0, then this body cannot move in this direction, but still it has a tendency to move in this direction, vertical direction. So, if we want to restrict this its motion in the y direction, so what we have to do? We have to make the algebraic sum of all the forces in y direction equals to 0. Let us say this is y axis, this is x axis. So, this is the two dimensional force system we are talking about. So, let us say this is the x direction, this is the y direction and our body is placed here. So, this is the two dimensional force system. So, if we still this body has a tendency for the motion, motion means what kind of motion it has now. Now, we have restricted sigma f x equals to 0 and sigma f y equals to 0, but still it has a tendency of motion along the z axis, means it has a rotating tendency. So, this body can rotate about this. This body cannot move in this direction because sigma f x equals to 0, it cannot move in y direction sigma f y equals to 0, but still it can rotate about, this is the z axis. So, it can rotate about the z axis. So, what we have to do? So, it means, so we have to write the third equation of equilibrium, that is sigma m. So, this is the algebraic sum of the moments of all the forces about z axis should also be 0, if we are talking about the two dimensional force system. So, for any body to be in equilibrium, so we have three equations. So, these are the three equations. So, statically determinate beams means, statically I will write in short, statically determinate beams means if any beam which can be solved by using these three equations of equilibrium, that is known as the statically determinate beam. So, how many equations we have? 3. How many variables we can solve? So, we can solve for 3 maximum 3 variables. So, it means if any beam which is having maximum 3 unknowns, maximum 3 variables as a unknown, then we can solve that beam. So, that beam may be statically determinate beam. But if we cannot solve that beam using these 3 equations of equilibrium, so it means that beam would be statically indeterminate beams, right. So, likewise we can classify the beams into two types, statically determinate and statically indeterminate beams. Now, let us see the examples of statically determinate beams. So, statically determinate beams may be simple supported. So, I will discuss more about these beams in next slide. So, statically determinate beams are simple supported beams, another may be cantilever beams and third may be overhang. Right. So, now the second is statically indeterminate. Statically indeterminate means these beams may be fixed beam, second may be continuous beams, and third may be propped cantilever. So, these 3 beams A, B, C, these may be the statically indeterminate beams which are not in our syllabus, and we no need to study all these 3 types of beams. So, we can solve these beams or we will study these beams in the further classes like 3rd semester or 4th semester, when we will go for the strength of material like subject, but for all the students it is not mandatory to study. So, we are skipping all these things, but we should know ki what kind of means how we can differentiate, or if we see the diagram, then how should we identify whether it is the fixed beam or cantilever beam or propped cantilever beam. So, fixed beam is generally represented by this diagram. So, just like in building constructions, the beams which you will see, the horizontal members which you will see, all these beams are statically indeterminate beams, because they are fixed at one end, they are fixed at another end. So, this type of beam, so it has 6 unknown variables if it is fixed. So, we cannot solve these 6 unknown variables using these 3 equations of equilibrium. So, this is the fixed beam which cannot be solved by this. Second is the continuous beam. If any beam is being supported by more than 2 supports like this, you can see in your building many beams are continuous beams from bedroom to the drawing hall to the balcony. So, these beams are moving out in a single span, but they are being supported by several supports. So, those beams are continuous beams, and we cannot solve these beams using this method. So, they are statically indeterminate beams. Again the propped cantilever. Propped cantilever means we know the cantilever is this. Let us say this is the cantilever, it is fixed at one end just like the electric pole, right. Or we can say if we another, let us say this is the cantilever beam, if we are talking about the beam. So, this is not beam, this is actually column. So, this is the beam. So, propped means we, if we provide the support at the free end of the beam. So, this is the cantilever, just like the diving board of a swimming pool, that is the cantilever beam. But if you put some support at the free end, then this beam becomes propped cantilever, just like the canopies or balconies or the porch in front of the houses which are used to park your car. So, those are known as the propped cantilever. So, like we have provided one prop here. So, this is also the fixed beam, we cannot solve this beam using these 3 equations of equilibrium. So, these beams are statically indeterminate beams which are not in our syllabus. Now, we will talk about the statically determinate beams. So, 3 beams are there. So, we will take one by one, but before this, because these supports are very important for us, you know. So, you are seeing here different symbols, I am using different symbols to represent the support. So, first we should understand ki how many types of supports are there, how these supports are represented, how many types of reactive forces are given by these individual supports. So, likewise we should understand all these things. So, we will take first the classification we have already studied. Now, we will take, we will consider the okay, if you want to simplify here by using the different you know the diagrams to represent the simple supported beam. So, this may be the simple supported beam, simply supported beam which is the beam which is being just simply supported like this. So, let us say this is just simply supported over these supports. So, simply supported. Cantilever means this is the cantilever, this is the diagrammatrical representation of the cantilever beam like this, one end is fixed, another is free. Overhang means some portion of this beam is being hanged. So, likewise either on one side or on the both side, depends upon the situation where you are using these type of beams. So, these 3 beams we are going to study. So, now before going to solve any numerical problem or to draw the free body diagram of these beams, first we should understand ki how many types of supports are there. So, supports for beams. So, there are 4 types of support. First is the simple support. So, I will try to explain this. Second is the roller support, roller, or sometimes it is known as the hinge, or sometimes it is known as the pin joint. Sorry, this is not, just a minute. So, this is the roller support. Next is the hinge support, hinge or pin support. and it is the fixed support. So, we have 4 types of supports. So, by getting the numericals on the in this subject, we will get the diagram and we will have to identify from the diagrams which kind of support it is and how we will remove those supports by drawing the free body diagram of any beam. So, simple support means ki just the beam is simply supported. So, sometimes you will get these kind of structures where this beam would be placed. So, this is the simply support, or sometimes you will get these kind of structures, one triangle, H lines, and this is the beam. So, this is also the simply supported beam. So, just beam is being simply supported over that, and when you will remove it. So, you will have to, let us say we draw the free body diagram. So, this is the beam. If we will remove this support, we will have one vertical reaction or one perpendicular reaction. Let us say this reaction is R 1, or if we will remove this, you will get here one reaction, because this is horizontal surface. So, you will get one vertical reaction, right. If it has to be tapered on that particular thing, so you will have to give the tapered reaction perpendicular in the perpendicular direction. Now, another one is the roller support, where in between two supports, if you will have some roller like this. So, let us say this is the beam and you have a roller. So, this is the beam and you have a roller, or sometimes it is shown by like this, one triangle supported by few balls, and this is the beam. So, this kind of structure if you will get, so you will have one reaction as in the case of simply supported, but here what is the difference? Here we have supports, roller supports, here we have simple flat supports. So, flat supports has high coefficient of friction as compared to the roller friction. So, whenever we want to reduce the coefficient of friction between the two bodies, then we can use these kind of roller supports. So, inside the bridge you can see we have the baller supports, steel balls are there to support the bridges. So, when you remove this, so draw the free body diagram of any beam and remove this or replace this support reaction by a support reaction, that is the R 1. So, जैसे आप इसको हटाएंगे, you will have to apply one reaction here. Now, next one is the hinge support. So, hinge support generally represented by this diagram. Let us say this is the beam and this is the hinge support, or sometimes it is also represented by this. So, by having some experience, we have to identify which type of support it is, because you see the simple support and pin support are sometimes are shown by the same kind of diagram, but maximum time you will see the different symbols, but sometimes you can get the similar kind of symbols. So, in that situation you will have to be more conscious, because we have only 3 equations of equilibrium. If we have these symbols on both the ends, then we will have to assume that either one of them will be simply supported and another will be pin joint. Sometimes the examiner can fix that joint A is fixed or joint B is hinged. If that situation is there, so it is simpler, relatively simpler situation, but if it is not given to you, then as per your experience or as per your knowledge, you will have to identify which kind of joint would be simple joint and which would be the hinge joint, right. So, when you have the pin support, then definitely you will have to be very much conscious. So, now the fixed support means you have fixed one joint. So, let us say this is the beam and this is the symbol of fixed. So, it means you have just fixed this particular end like this. So, neither this beam can move in this direction. So, you have one horizontal reaction, nor this beam can go down. So, you have vertical reaction, and in addition to this you cannot rotate it. But in the pin joint, and what is the difference between pin and this? Pin joint was like this. So, you cannot travel this body in x direction, because this joint will provide you the one reaction in x direction. It cannot go down, because this beam, this support will provide one vertical reaction, but apart from this there is no third reaction, because this body is free to rotate about this. So, this is the hinge joint or pinch joint, just like the joint or hinges in your door. So, that is the pin joint, but when you will fix it like this, now it cannot rotate. So, it means third reaction would also be there. So, what that third reaction would be there? So, if you draw the free body diagram of this beam, so one vertical reaction, here you will see the two reactions, like this is the beam. So, one reaction, let us say it is R vertical and this is R horizontal. So, here in fixed support you will have two reactions, one R vertical, one is R horizontal, and the third reaction you will have, let us say you apply one force here and it will try to rotate in this direction. So, you will get one reaction that is in the opposite direction, that is the M, understood. So, likewise, why we need this information? Because we have to draw the free body diagram, then we have to use these symbols for drawing the free body diagram. Now, type of load, because these information are very important. So, description would not be given, only the diagram would be given and you would be asked to solve the reaction, support reaction of a particular beam. So, type of load are generally of three types which are in our syllabus. So, first is point load, second one is uniformly distributed load, and third one is the varying distributed load. So, these are the point load, or sometimes it is known as the concentrated load. So, like vectors, if any load is acting at a particular point, let us say in this direction, this is the beam, let us say this beam is AB and we have one load like this. So, it is represented by a arrow, it may be vertically downward, it may be in this direction, it may be in this direction, but it is always represented by a arrowhead and arrow. So, that is known as the point load. So, let us say this is the body and load is acting at this particular point. So, this is the point load, right. Now, second is the uniformly distributed load, means distributed load, but it is the variation distribution is uniform, or sometimes it is in short it is known as the UDL and this is known as the VDL. Different books have different notations, but please do not be confused, but just identify with the help of the diagram which is given in the book or in the exam. So, uniformly distributed load is generally represented by like this. So, it represents the intensity actually. So, intensity of load by different same sized arrows. So, over a span of this particular length of beam. So, like this is the beam AB and the length of the beam is L and the intensity of this is W small w Newton per meter. Here you will have capital W. So, this is the W Newton, that is the load itself, but here what you will see Newton per meter. So, this is the intensity which is W Newton per meter at the point A and it will remain constant throughout its length and at end B also the same. So, this is the uniformly distributed load. Sometimes to avoid the time, so we can draw it as like this also. So, this is one beam supported by two supports and the intensity is W Newton per meter. Sometimes it is also given like this. Why I am explaining this? Because you can get these two different representations in the numericals. Now, third is the varying distributed load. So, let us say we take an example of this beam and this is the varying intensity. So, variation means let us say at this end it is W Newton per meter, at this end at end A the intensity is 0. The intensity of the force you can see clearly, the intensity of force is increasing while we are moving from left to right end. So, let us say the length of this beam is L and while moving from one end to the another end the intensity is varying, right. So, this is the representing way of showing all these three types of load, but now the situation arises that we have three equations of equilibrium. sigma f x equals to 0, sigma f y equals to 0, sigma m equals to 0. So, while calculating the net force, so we should know ki this we can directly say ki the value of this load, numerical value of this condition is W. Let us say it is W 1, W 2, angle is given theta 1, this is W 3, angle is theta 3. So, likewise we can easily calculate the algebraic sum. But what would be in this case? What would be the total value of this load? Total, how we should calculate it? So, just what we can do, it looks like a triangle, sorry, look like say rectangle. So, the height of this rectangle is how much? The intensity of this arrow. So, if we draw the equivalence rectangle, so the area of that rectangle would be equal to the total value of this load. How? We can understood by this also. So, it is W Newton per meter, and what is the total length? Length is L m, length L meter. So, in 1 meter it is n, W n. So, in for total L, so product of this and this. So, what would be? So, let us say we consider this is the height of this rectangle, this is the width of the rectangle. So, whatever would be the area. So, area of rectangle would be equal to W multiplied by small l Newton. So, this is the, you can see the area means this multiplied by this. So, this is Newton per meter and this is meter. So, meter will be cancel out, likewise Newton per meter into meter. So, meter will be cancel out. So, Newton. So, what would be the area of this diagram? So, that area would be equal to in Newton, right. So, area Newton means it is equal to the force. So, similarly we can do for the bearing distributed load. So, here the force is equal to area of triangle, because it is like a triangle. So, area of triangle will be equal to half into base, base is L into height, height is how much? So, here height is W Newton per meter. So, this is L meter and it is W Newton per meter. So, this will be cancel out. So, what would be this? W L by 2 Newton. So, this is the force. So, now we can add vertical components of all these forces to get the total force, but the next question arises ki where we will apply these forces, because we need to calculate the moment also. So, let us say we want to calculate the moment about this point. So, easily we can calculate the moment of this W 1 is equal to W 1 into L 1 clockwise, but what would be in this case? So, that we can do. So, we have to replace this UDL by a single point load. So, how we can replace this? So, we have to calculate the force. So, this is the W Newton per meter. So, we can replace all this and we can apply the load at the midpoint. So, the load value would be how much? W into L, but where it would be applied? L by 2 from the this end or L by 2 from this end. So, this is the position of this load, but in the case of triangle where we will apply this load. So, value of the force would be W L by 2, but where we will apply? So, where would be the centroid of this triangle? Triangle centroid is at 1/3 from this end and 2/3 from this end. So, we can apply one force whose value is W L by 2 and at a distance of 2 L by 3 from this point and L by 3 from this point. So, likewise you can see easily. So, we have converted this load into a point load. So, now we can draw the free body diagram, let us say A, let us say B, and we can apply one load here W L by 2 and this length is L by 2 L by 3. So, now we can easily calculate the moment of this force about this point. So, that moment would be equal to W L by 2 into 2 L by 3, but in this situation we could not calculate it. So, now we can easily calculate. So, now you can easily draw the free body diagram of any beam. Let us say you want to draw the free body diagram of this beam. Let us say W 1, W 2 Newton per meter. I am quickly drawing this diagram and this is the free body diagram of this. So, what you can do? So, you can draw the free body this beam, this is the hinge support. So, you can have two reactions R 1 R 2 and let us say this is L 1, this is L 2. So, in the middle you will get one load W into L 1. So, L 1 by 2, L 1 by 2 and here this is the point, and what we will do? You will have to apply one force here W 2 L 2 by 3, and at what distance from here? 2 L 2 by 3 or L 2 by 3. So, likewise, and one reaction here because this is the roller support. So, we will take all these things in the next lectures also. So, kindly bear with us and attend all the lectures. Thereafter, you will be able to draw the free body diagram of subsequent beams. So, thank you so much for listening this video. Thank you.